Hello everyone, welcome to the another video of code complexity. So previously we learned about what is code complexity and what are the different types of code complexity and why code complexity matter to the developers and what is cyclomatic complexity, and we learn about how to calculate the cyclomatic complexity, and we learn about the cognitive complexity, and we see how to measure the code complexity, and we learn about how to reduce the code complexity. There are different types of code complexity we see, and we learn about the code complexity reduction by a demo. So if you miss anything, you can watch my previous video in the playlist. Link is in the description, and you can find the code over here, and the link is in the description. So let's start another demo of code complexity. So let's start. So previously we covered this particular example and how to fix it, and the solution also available in the another branch. You can check out and check the solution. So now today we are gonna discuss about the how we can identify this is the cyclomatic complexity and this is the cognitive complexity. So here is the another example. So let me split this window in two parts. Okay, I think now code is pretty much visible. If not, please let me know. Okay, so here are two functions available in the same file. I put them side by side so that we can easily see that. So over here there is a function name is get employee basic salary by their role, and in this function we are passing a role, and as per the role we are calculating the basic salary. We are returning the basic salary of that particular employee. So if the role is CEO, then the salary will be basic salary will be this. If it's senior BP, and then salary will be this, BP. So like that, if the guy is intern, then salary will be this. So we can see that its complexity is 11, correct? And here we are having the another function whose complexity is also 11, and over here we are calculating the uh, sum of prime number. So by seeing those function, these two function, we can see its complexity is same. Cyclomatic complexity is same. But if we talk about the cognitive complexity of these two function, so definitely the cognitive complexity of this particular function is high. How? I will tell you. So basically, if any person come to this particular method or function, he will be able to identify easily what's going on there. He will require less effort to understand this function. So that's why its cognitive complexity is very less. And when this function, this particular user come to this function, and he will see, okay, so here we are having the total, and the I value is 1, and then we are iterating one for loop to the max limit, and then we are starting another loop, and then we are checking whether this number is divisible by the j or not, and then we are calculating the sum of it. So by analyzing this particular function, we need to require more effort to understand it. So that's why this function is having the higher cognitive complexity, and we will see how to reduce the cyclomatic complexity as well as cognitive complexity in the upcoming videos. So I hope now you guys are clear about the what is cyclomatic complexity and cognitive complexity, and why it's matter. So let's start with reducing the cyclomatic complexity of this function. So before we begin to remove its complexity or refactor this particular function, let's create one more branch and name it solution underscore of example 1. And so over here we can see that we are having the employee, and employee is having the role, and he is having the basic salary. So what we can do to refactor this particular code, we can create few more class. So as we learned previously, we can reduce the complexity by creating more classes with the class substitution. So let's create more classes over here, and name that particular folder or package a model. And in this we are gonna create uh, few more classes. So let's create a Java class, name as employee. So let's have each employee will have one role. So let's have one function string get role, and as we require, each employee will have the basic salary. Okay. And as we are having this different kinds of role over here, so each and different kinds of employee hierarchy, so we will create more employee over here. So we will name it CEO. So for we are going to create our first employee CEO, and this CEO class will inherit or implement the functionality of employee class. So let's implement its method, and as we are having the role CEO, so we are going to return the role CEO and its salary. Okay. Likewise, we are having the different employee role. So we are going to create new class, or we can copy paste, and we will say senior BP, and we will copy its value over here, and let's rename the BP, and its salary is senior manager. make it capital as we are having everything is capital, and paste over here. The another class is manager. Implement C, employee interface. Let's implement its method. Role is manager, and its salary is this. So, and now I think these classes are enough. So let's close all time and come to the our example. Okay, so we have created few roles over here, and let's see how we can reduce the complexity. So instead of modifying this particular function, I'm creating one more function with a similar functionality. Public double get employee basic salary by their role with less complexity. And instead of passing the string role, we are going to pass the employee. And so now we want the salary, so we will say return employee dot basic salary. And if we are gonna see the outcome of this particular function, so let's see the salary of CEO. So instead of this, we will say role with less complexity, and we will pass the object of CEO class. Invite is saying okay. So let's see and run its output. So we can see here one function which is having the higher complexity is having the same output, and the another function which we written in a single line with the code replacement with some creating some new classes is much clear now. Okay, so we can having one more benefit over here. Suppose by mistake, if anyone passes any wrong information over here, what will happen? We will get the output as 0. But over here we are having defined the pre-existing role, so role cannot be changed. So if we are going with class approach instead of this string, we are having the fixed role, so role cannot be changed by the external entity, or we can say the CEO role, employee role, and CEO manager, and this developer role cannot be changed until unless the company is going to create one more role for the specific designation. So before we move to the next example, let's commit this and push it. So git status, and we are having the modification of this file. Get add src, get commit minus m, code refactoring of example 1, get push origin and the name of the branch. So now you can find the solution of this particular code refactoring in the branch name, solution of example 1.